So here's a flowchart of the specific topics that we cover in this module. In the first two videos of the module, we covered basic concepts related to entity routing. So we talked about basic and transfer nodes and their properties and how they can be used to specify a destination node for the entities or to select an outbound link for the entities to take. So in terms of entity destination, we have two cases. The first case is when the entity does not have a destination node set. In this case, in the first video, we covered free space movement, where we do not have a network of link objects. In the case where we have a network of paths or connectors, we talked about the case where there is only a single outbound link. For the case where we have multiple outbound links out of our transfer node, we learned how we can use the properties of the transfer node to specify a specific link for the entities to take. And we also talked about selection weights very briefly in the first video of the module, while in the third video of the module, we looked at using selection weights for probabilistic and conditional routing, and also we learned how we can have compound probabilistic and conditional expressions for the selection weight property of our link objects. So the second general case that we talked about in the second video of the module was the case where the destination node of the entity is set. So in this case, we talked about how we can use a set node step or the entity destination type property to specify the destination node for our entities. So we talked about outbound link preference and outbound link rule and the different situations that can happen based on the choice of these two properties. In the fourth video of the module, we talked about dynamic routing using node lists. So in this case, our entities can select their destination dynamically from a list of candidate nodes. And this decision depends on the state of the system when the entity is trying to figure out its destination node. In this video of the module, which is the fifth video, we're going to talk about routing with sequences in sequence tables. And in this case, our entities have a predetermined sequence of objects or nodes that they need to visit as they move through the model. So in this video, we are going to talk about routing with sequences. So we use sequences or sequence tables when we have predetermined routings for our different entity types in the model. So to see how we can implement sequences in Simio, we're going to use a very abstract model of an airport that you can see here. So we have three airlines, basically, airlines A, B, and C, and we have equal arrival rates for all three airlines. So we have the check-in process first for each airline, and then all of the passengers will go to the document checkpoint, and then airlines A and C are located in the north terminal, while the B passengers or passengers for airline B go to the south terminal to be screened. So let's go to Simio and build this model. Okay, so let's start building our model by putting the objects in the facility view. So we have our three source objects for each airline. We will have three check-in servers for the three airlines. Let me zoom out a little bit. And then we're going to have a single server object for the document check. And finally, two screening checkpoints for the north and the south terminals. So let me go ahead and rename my objects here. So I have, let's call them passenger A. And then we're going to have passenger B and passenger C. So we have A check-in, check see if I can get this right. There we go. We're going to have B check-in and C check-in. C check in. And then we have our document check, doc check. And we have our advanced imaging technology A, AITA, and we have AITB, AITB. We can also use an underline to make the names more informative. Alright. So I also need a sync, of course, to destroy the entities when they leave the system. So let me use paths again to connect my object. So A's passengers for airline A will go to A check-in, and then everybody will go to the document check. But A and C will go to AITA, and then they will leave the system. Passengers B will go to B check-in, and then of course to doc check. But these guys will go to AITB and then leave the system. Passenger C will go to C check-in, and then again document check, and they will go to the AIT screening and then leave the system. So we have the basic structure of the model set up, so I can hit run and make sure that everything is connected and we don't see any runtime errors in the model. So I'm going to let the model run for a while. Of course, you guys definitely need to do it. I'm going to stop and continue just to save some time here. So as you can see, we don't have probabilistic routing here anymore, but rather we have a predetermined sequence of stages that my model entities will go through, and we have different sequences based on the type of the entities. So what I need is basically three instances of model entities. I'm going to have A, B, and C passengers. So let me call these guys A, call these guys B, and call these guys C, and give them different colors. So I want A's to stay green, I want B's to be, let's choose a lighter blue color here, and C passengers to be red. Alright, so now again, when I look at my sources, all of the sources are creating type A, so I'm going to tell my B source to create B passengers and C source to create C passengers. And let me also set the arrival process. So we are going to have 1 divided by 240 in hours for the inter-arrival time for all of them. So I'm just going to copy and paste my inter-arrival time expression, which is going to be the same for all of my sources. So now I can go ahead and run the model, and as you can see, we have the check-in processes and the document check and so on. So we haven't set up the capacities yet. So I'm going to have 3 units of capacity at my document check. I also, when I ran the model, I realized that I haven't set the units for these two sources. So again, these are also in hours. So again, as you can see, this is why we run the model every time we make a modification to the model, because we want to make sure that as we add new features to the model, they are implemented correctly. So let me just make sure that every arrival expression is in the units of hours. So hours and hours. So now when I run the model, I don't see the queue back up here again anymore. So as you can see, up to this point, we have everything correct. So everybody goes through the the exact same process that I need to go through. But here we have this default probabilistic routing. So 50% of entities are routed to A, and 50% are routed to, or I should have called this north and south. Sorry about that. AIT north, AIT south. So 50% go to the north, 50% go to the south. What we want here is this type-based routing. So of course we can use selection weights to do this, but we would like to show you another approach using sequences. So what I can do here is go to data and then tables, and here we have an option to add a sequence table. So first I'm going to have separate sequence tables for my 3 airlines. So I'm going to have a sequence table for airline A that goes to check-in A and then document and north terminal screening. For B that go to check-in B, dock check, and south terminal imaging or screening step, and C that go to check-in C and dock check and north terminal. So let's create our 3 sequence tables. So I'm going to have A, let's call it SEQ-A, sequence A. So when we add this sequence table, you will see that Simya automatically creates a column called sequence. So when we click on this drop-down menu, we'll see different nodes in our model available to us. So what I'm going to have for A, they first go to check-in A, so A check-in, and then they go to dock check, and then as you can see they will go to the north terminal or AITN. So we have AITN, and then they will leave the system by going to the sink. Input at sink. So now I have the sequence of the nodes that my A customers visit. So I have input at check-in A, input at dock check, input at AIT north terminal, and then they go to the sink. I'm going to have another sequence table, and I'm going to call this SEQB for my airline B passengers. So they will go to B check-in, and then they will go to the dock check with everybody else, and then they will go to the south terminal AIT south, and after that they will leave the system through the sink, input at sink. So now I have B check-in, dock check, AIT south, and sink. And my third sequence table for C passengers, I'm going to have check-in or C check-in, input at C check-in, and then dock check, and then input at AIT north, and then I'm going to have input at sink as the last node that these passengers visit in the model. So now I have my 3 sequence tables defined. So the differences is in the check-in station that they visit and the terminal that they go to. So now the last thing I need to do, or actually I need to do a couple of steps to complete the model. So I'm going to select my model entity object instances, and then go to the initial sequence and set the initial sequence property. So I'm going to select A, then say my A passengers will follow sequence A. So now Simyo refers to my SEQ-A table right here to determine which nodes these customers will visit. I'm going to select B and then choose sequence B as the initial sequence property value. And also for C passengers, I'm going to choose sequence C. So now I can go ahead and select my output nodes, all of my output nodes in the model, and tell Simio that the entity destination type will not be determined by the link weights or selection weights, but by sequence. So in my drop-down list, I have several options. We have seen these before, or at least some of them. So I'm going to select by sequence. So now I'm going to run my model, and what I expect to see is that blue passengers will go to B check-in, dock check-in south, but red and green ones will go to the north terminal. So let's run the model and see if that in fact is working. So I have green and red on the top, and I have blue passengers in the south terminal, which are the passengers for airline B. Also note that here we have path objects in the model. So for example, even if we don't have the sequence defined from the source objects to the check-in process, there is no other way that these entities can go through. What sequences allow us to do is to have entities travel in what we call free space. So if I go ahead and remove all my path objects here, so there are no path objects in my model, and also I'm going to select my model entity object instances and then go to their property value called initial network. And as you can see, it's defaulted to global network that we previously had, but we have removed all the path objects. So if I click run now, I will get this runtime error that says failed to initiate transfer, and basically says, well, there are no path or links that I can use. So I'm going to pause simulation, stop, and then select my model entity object instances, and this time I'm going to choose no network or free space. So now entities, when I run the model, they will flow in the free space, so there are no path, but they choose the shortest straight line that goes from the output node to the input node of the destination, but they're still following the same sequence that we defined. So now we understand why we needed to have this sequence table that says, well, where do these passenger A type go, since we don't have the path that limits our destination to the A check-in. Also note that you can move objects around like we could before in the case where we have a network of links between our objects. So an alternative approach to model this routing problem using sequences is to use a single sequence table that has a column that determines the type of the entity and then its corresponding sequence. And we have seen a more comprehensive example of using a single sequence table, how to bind it with external data sources, and also how to incorporate different processing times on different servers for different model entity types in a related video. So for those of you who have watched the related video, this should simply be a review of what you already know. So using a single sequence table is a two-step process. The first thing we need is a data table that has the type of the entities and the associated mix of the entities in it. So what we need is a data table that I'm going to call passenger mix. And then what we have in this table is a reference to an object, which is an entity reference. You will see that we have the three entity types listed here. So let me go ahead and rename my property here. So I'm going to call it passenger type. And I have three types of model entities in my model. And also I'm going to have a standard property, and this time I'm going to use an integer for my mix column, because we know the arrival weights for all three are the same, so I'm just going to have 1 for all of these. This mix column allows us to support the cases where we have different proportions for our model entities. So the next thing I need to do is set the passenger type column as a key column so that I can relate my sequence table that I'm about to create to this data table that I just created. So as I mentioned, the next step is to create the sequence table. I'm going to call it all passengers SEQ. So we have this sequence, and what I'm going to do is first use a foreign key. Let me select my foreign key here, and the table key is going to be my passenger type column in my passenger mix table. So I'm going to rename this also to passenger type and move it to the left. So now in this table I'm referring to my data table to determine the type of the model entities. So I'm going to have A passengers that go to A check-in, and then dock check, and then AIT North, and then sync. And these are all A customers. And then I'm going to have B customers that first go to B check-in, and then go to dock check, and then go to the South AIT, and then they'll leave the system through the sync. And finally, I will have my C passengers that go to C check-in, and then dock check, and then AIT North, and then sync. And I forgot to select my entity types here. So now I have completed my sequence table. Now I need to go back to my model and tell Simio to use this sequence table instead of the separate or individual sequences that we previously implemented. Also note that in my passenger mix table, now I can also see the sequence of each entity type since I'm using this column as a foreign key in my sequence table. So that's how the two are related together. So now we need to go to the model, and this time I'm going to only use a single source. So I'm going to remove all my sources and just use a single source to create all three type entities. So entity type will be determined from my sequence table, my data table, excuse me. So passenger type, passenger mix table, and then my passenger type column, which is this column right here. So I either have A, B, and C. The next thing I need to do is to go to table reference assignments, and before creating, I want to determine the type of the created entity by referring to my passenger mix table and randomly choose a row based on the mix column that I have assigned. So I'm going to have my passenger mix table and then my mix column and random row. So passenger mix table, mix column, random row. So what it does for me is that when an entity is created, Simio refers to my table and then uses these proportions to determine which type of entity this entity will be. So I'm going to select the output node of my new source object instance and set the entity destination type property to by sequence. And also I will need to set the arrival process. So this time I'm going to have 1 over 720 instead of 1 over 240 since we're combining all three arrival processes together. And of course the unit is hours. So now I can go ahead and run my model to actually verify that our single sequence table is implemented correctly. So I'm going to watch my model run and verify that I see green and red passengers here, blue passengers in the south terminal, and also to verify my check-in process. And one thing that I just noticed by looking at this model is that I forgot to increase the capacity of my AIT North to 2, and that is why I see this line backup here. So it's not going to affect any of the routing logic that we implemented so far in this video, but to make our model correct, I'm just going to increase the capacity to 2 as specified in the problem. So again, this is another example of a case where running the model and watching the model run can really be helpful in terms of verification. So now I run my model again and I shouldn't see the queue back up here. So in this video we talked about routing with sequences. In the first case we defined separate sequence tables, one for each entity type, to implement our routing logic. In the second case we used related tables, and specifically a mixed table or a data table and a single sequence table that consists of the routing logic for all of our entity types to implement our model. We also used free space movement in this model, and we saw that when we use sequences, then unlike what we saw in the first video of the module, entities will not select the closest external input node as their destination, but instead they will simply follow the sequence that we specify. So when I run this model, it doesn't matter which node is closer, my entities will be routed to the node that I specify in my sequence table.